Hi everyone, welcome to IT Explain with OpManager. I'm Vishnu and I'll be talking about network performance monitoring with OpManager. Network performance in modern IT ops depends on more than just checking the uptime of your key network nodes. You need to monitor the quality of the network connection, the health of your network devices, interface performance, and most importantly, you need visibility into the network itself. This is why OpManager gives you multiple ways to view your network. Depending on your requirement, you can look at your network with a dashboard, a map, or an inventory. With dashboards, you can isolate devices, interfaces, and metrics that you want to keep a close watch on. They can be a part of your mission-critical IT systems. Maps give you a contextual view of your network and their roles in service delivery. The inventory is a repository of all the devices you're monitoring, and you can see every device is classified based on the roles and further subdivided based on their category, vendor, and group. Now, how about visibility within a device? Let's take a look at the core access switch that's connected to a server. This is a dedicated view for this device. In OpManager, this is known as device snapshot. As you can see in this device snapshot, for each device, OpManager keeps track of the basics like availability, packet loss, response time, interfaces, and device health and performance. Let's go over each of these. OpManager performs uptime monitoring by pinging a device at regular intervals. Uptime monitoring is set up automatically for all devices after discovery, but you can enable and disable downtime alarms here. Go to the sandwich icon, click on Select Availability Monitoring, and click on the toggle button to enable or disable availability monitoring. By enabling status polls, OpManager checks the uptime status of your devices, whether it's up or down, or in some other state, and generates alarms for downtime. You can also customize the availability monitoring interval. This determines the frequency at which OpManager pings your device. For critical devices, frequent checks are preferred. Let's set this up for 1 minute. Now go to the sandwich icon, click on Edit Device Details, and now you can change the uptime monitoring interval and also the monitoring mechanism used by OpManager to poll your devices. Here, under the Availability Monitored Via section, you can customize the mechanism used to ping the devices. By default, OpManager uses ICMP, but you can also choose SNMP or TCP. You can also set up your device's uplink dependency here. For instance, this is an access switch selected. It connects my server to a core router. So what if my router goes down? OpManager won't be able to poll my switch or server and will generate multiple alarms. But if I set up uplink dependency here, I can reduce the number of alarms. Now, OpManager will be tracking the availability of your devices with this dial right here. As you can see, you can track various things like availability timeline and history by using these dials. Now, you can see that OpManager also tracks the packet loss and response time of this device. This is particularly important as the quality of the network connection is as important as the status of the connectivity. If you want to set up alarms for these metrics, you can set up thresholds. Let me show you how thresholds work for packet loss. You can customize things like the monitoring interval, the unit of the thresholds, and the thresholds themselves. Thresholds are numerical limits you can configure to generate alarms with OpManager. As you can see, OpManager supports 3 threshold values. Each threshold represents a particular severity in an increasing order. You can set up threshold conditions as increasing, decreasing, equal to or not equal to based on the type of metric that you're monitoring. For instance, if you want to get notified of a mild increase in my response time, I can set up my attention threshold. Similarly, the trouble threshold is for more pressing issues and the critical threshold represents absolutely critical issues. Now, the alarms generated for each of these alarm severities will be color-coded and tagged as such. So this gives you a way to prioritize the right issues and alarms. The RIAM value is used to mark the alarm status as clear in case the monitored metric reaches a safe value. In addition, the consecutive times field is used to mark the number of times the thresholds are violated before generating alarms. The same configurations can be done for response time monitoring as well. This is the threshold configuration section for response time. Now let's talk about interfaces. It's easier to monitor interfaces associated with your device in OpManager. When you discover a device, you have the option to discover the interfaces associated with it as well. You can see this in the Interfaces tab. For each interface, you get a complete overview of the name, type, and traffic. If you click on the interface, you will be taken to a dedicated monitoring snapshot for the interface. I'll choose this interface. Now, when it comes to interfaces, you can monitor the uptime and set up alerts for errors, discards, and traffic utilization. Just like how we showed you before, you can set 3 levels of thresholds and rearm for both transmitted and received values. This applies for traffic utilization, errors, and discards of your interfaces. Once you set these up, you can also monitor interface performance with the help of graphs. You've seen the steps to monitor the uptime, packet loss, and response time. Now let's understand how OpManager monitors device health and performance. Go to the Monitors tab. When each device is discovered, OpManager identifies, classifies it, and curates a set of performance monitors for it. Let's take a look at the list of all the monitors. Each monitor is curated for a device based on its category, vendor, and model. So for this switch, we can see metrics like packets and CPU. To start monitoring something, you can just enable it and configure the threshold. Let's choose CPU utilization here. Now we can configure the 3 threshold levels like we did before. Based on your estimate for what the normal value of the CPU should be, you can set up thresholds. OpManager also supports AI-powered thresholds if you want to automate this entire process. While setting up thresholds, you can choose the option to generate graphs for the monitored metrics. Once generated, the graphs will look something like this. So this is how OpManager helps you keep track of the uptime and performance of the devices in your network. If there's any network degradation, you'll get instant alerts. You can also investigate variations in KPIs like packet loss, response time, CPU, memory, errors, discards, etc. That's all for today. Check out our other videos in the series to learn more about IT monitoring with OpManager. Thanks for watching. See you in the next video.